Okay, first thing, let's go through one by one concepts. Then we'll go over questions where we're working on those concepts. Number one concept of yesterday that came back multiple spots, okay, is when you look at a function versus the inverse, the domain and the range flip. The domain of the original function becomes the range. The range of the original becomes the domain. Okay, remember the x's and the y's switch? Okay, it comes back, like I said, in multiple spots. So that's number one. So the first two questions on your homework, that's all you were doing. So those hopefully should have taken you more than about 30 seconds to do those two questions. Because when they gave you all the coordinates and they say find the inverse, all you had to do is flip the coordinates and you're done. Okay? So there's the first concept. Second concept then was getting into finding an inverse, finding the equation of an inverse. This isn't on your test, but let's say I put this on your test and said, rather than actually doing it, explain to me how you would find the equation of an inverse. What would you say, in general?
Plug in y for x and solve.
Yeah, switch x and y, and then resolve for y. That's the process. When you're done resolving for y, that's your inverse function. Okay? So that's the process. That's what you were doing on numbers 3 through 18 in the middle section of your assignment. Flip the x's and the y's, and then resolve. We will talk about, by the way, numbers like 15 through 18, where they added in like a y is greater than or equal to 0. That's what we'll add that today. Okay, we'll get into that. Let's go to a third part then. Third concept from yesterday. How do I verify if two functions are inverses of each other? Again, what's the process in general? Explain. What do? How do I check to see if two things are inverses? What is it? So when you do your composite functions, when you take one and plug it into the other, it should simplify down to x. And then when you take the first and plug it into the second, it should also. Remember, you got to do both parts. You can't just do one. You got to plug in, let's say, f of x into g of x, and you have to plug in g of x into f of x. Okay, you got to do both. They should both simplify to x. If they do, they're inverses of each other. If they don't, they're not. Okay, so that's a way to verify. Then the last thing we talked about was graphing, and there was a couple of things with graphing. Refresh my memory when you look at a graph of some equation. This goes back a little bit before yesterday. How do I know if something is a function? Let's start there. It passes the vertical line test. How do I know if the inverse is a function?
Horizontal.
Passes the horizontal line test. When you've got a function that passes both, that's what's called a one-to-one function. If it passes both the vertical and the horizontal line test. And that's one of the things we'll add in today. We'll talk a little bit more about that. The only other thing we added yesterday, I was doing it on the whiteboard, was the concept that a function and the inverse, when you look at their graphs, they are reflections of each other over the line y equals x, that diagonal line. And we'll look at that. Those were the questions on the back side of the sheet, numbers 25 through 28, where you were trying to graph those. We'll talk about those too. I'll give you what I think is an easy way to try to graph those, okay? But let's start then. So those were the concepts. Those were the main ideas. Let's start on the front side of the worksheet. Questions? Anything you want to go over. And now is the time to ask. I said to every class, please don't just sit there and be like, well, I really wish we'd go over this one, but I'm not going to ask. You have a test in 2 days. Ask if you have a question. I guarantee you're not the only person who has a question on that problem. So if you have one, ask it. Okay? Anything on the front side you want to go over? Yeah, what do you got, Ethan?
Let's do 13.
Okay, let's take a look at 13.
I get how to do it. I can do it. It's just I don't get why that.
Let me take a look here. Okay, yeah, we'll take a look. So let's take a look at number 13. And we're going to actually do a little bit more than what we normally would. Oh, sorry. Yeah, you sure can. Anybody else need a sheet from yesterday? Anybody else wasn't here? Okay. Okay. So let's start with number 13. So here's what I'm going to do. I'm going to add some stuff that's not on the worksheet that will help you for the test. And I think it'll help your understanding too. Okay? So first thing, when you take a look at this, I'm going to add a graph so you can see it. You don't have to do it for the assignment, but this is something you should be able to graph by hand. Okay? You need to be able to do that on the test based on the shifts and stretches and all of that kind of stuff, the transformations. So first question, if you graph this, what general shape is it? It's a parabola, right? Because you're dealing with squares. What does the plus 3 do to the parabola? Moves it to the left 3. So if you were to graph this, I would come over here and go to the left 3, I'd put a point, and then I'd sketch in my parabola. There's my original function right there. Okay? Quick question, and again, they don't ask you this on the worksheet, but it'll help you for the test. Is that a function? Yeah, passes the vertical line test, right? Will the inverse be a function? No, why not, Preston? Because this would not pass the horizontal line test. So we already know in advance that the inverse is not going to be a function. Okay? Now, the point of this problem is let's actually find the inverse. Here is where we do that process. Let's switch the x and the y. Okay? There's step 1. We said you flip the x's and the y's and then resolve. So now I need to get y by itself. First step of getting y by itself is what? Get rid of the squared. Yep. Take the square root of both sides. So we end up with the square root of x equal to y plus 3. One quick thing that we mentioned back previously. Whenever you take the square root in an equation, what do you always have to have? Plus or minus. So there is a plus or minus in front. And now, what's the last step? Yeah, subtract the 3 over. So the inverse will be, I'm going to put this down as plus or minus the square root of x minus 3. There's your inverse function right there. Now again, so that's really all they were asking you to do in the problem. I'm adding stuff because there's things you need to be able to do that you're going to see on the test anyway, like graphing it by hand. If we now take a look at this, let's say I graphed this. You have a square root function with a minus 3. What does the minus 3 do to the graph?
Down 3.
Yeah, because that minus 3 is not under the square root, that means it's a vertical shift down 3. So if I were to take this, let's say I went down 3, there would be the starting point, and here's the idea behind it. The positive square root from that point would look like this. There's your square root function, shifted down 3. But then you also have a negative square root. There's the other half. And if you take a look at the line y equal x, there's your reflections of each other right there. Okay? There's your diagonal reflection that went from vertical to now horizontal when it gets reflected over that line. Okay? Like I said, you didn't have to do all of this stuff for the assignment, but it will help you when you're trying to understand everything and put it all together. Okay? Yeah, Aiden?
Can you go over number 8? Because I feel like it should be a negative.
Yeah, we can take a look. Sure.
But they actually said it's a function.
Sure, let's take a look. So number 8. We've got y equals negative 3/4 x plus 5. And again, if we go through, I'm going to do more than what we normally would do because of the fact that it will help you. If I'm going to graph that, this one's linear. Okay, we're just graphing a line. Plot your y-intercept. And then from there, we'll go down 3 over 5. There's the graph of the line. Is that a one-to-one function? Let me ask you that. I'm kind of asking 2 questions in one. Why, Easton? You're right, by the way.
The vertical and the horizontal.
Yeah, passes both tests. Passes the vertical line test, and it passes the horizontal line test. So that means I know that that's a function, and I know that the inverse is going to be a function. Okay, let's find the inverse. We flip the x and the y. And now we start solving for y. Subtract the 5 over. How do I get rid of the negative 3/4? Okay, we can do it in a couple steps. We could do it in one step. You could multiply both sides by -4 and kind of clear the fraction. I'm going to check to see what they do on the answer key to try to be consistent with it. What if I wanted to do it in one step? What would I do? Yeah, just multiply by the reciprocal. Okay, which I think that's the way I'm going to go about it, just so we get to the answer quicker. So I'm going to multiply by a -4/3. When I do that, these will multiply to give you 1. And then I need to multiply this whole thing by a -4/3. And now I can distribute. Okay, so I get -4/3 x. Negative times a negative, this becomes a positive 20/3. Okay? Think of this as like 5/1. Numerator times numerator, denominator times denominator. There is your inverse function. Okay, what do they have on the, is that what they have or not? Yeah, it is. Okay. Did you find your mistake? You had a -20/3? Gotcha. Okay, that happens.
So how do you graph
Okay. So now let's say we graph this, yeah, so that we can kind of take a look at the reflection. It's a little bit harder because of the 20/3, so we're going to have to kind of approximate it. But 20/3 is what as a mixed number or a decimal? 6 and 2/3. So we'd come up here to approximately 6 and 2/3. Let's say it's about right there. And then we use our slope. We go down 4/3. Which would be about right here, somewhere in there. And we draw that line in. And the line y equals x would be like right here. Where, let me do it in a different color so it's easier to see. Where this part of the line gets reflected to here, and that part of the line gets reflected up to here. Okay, so they are still, it's a little bit more confusing to see when you're dealing with lines, but they are still reflections of each other. Okay? And again, notice the inverse is a function, because it's a line. Okay? Let's go to the next part here for a second. Anybody have a specific one out of 15 through 18 that you would like to go over? Otherwise, I'll just pick one, but I want to make sure we go over one of those. 15 through 18, any specific one, or should I just pick one? All right, let's do number 15.
Can you go back to 6 after this then?
Sure. All right. Same thing again. I'm going to start by graphing this so that we can take a look at what's going on, because I'm guessing that this part probably confused you a little bit. Okay? In terms of why do they have, or like on the next, on number 17, why is it y greater than or equal to 8? Why is that there? Okay, and we'll talk about why it's there in a second. Let's start with the graph though, just so we can see what's going on here. We've got a square root function. What's the -2 do to the square root function? Moves it to the right 2. That's a horizontal shift because it's under with the x, and it's the opposite direction. So we would have, there's your sketch of the graph right there. Okay. By the way, just a quick heads up as you get ready for the test. What I just did, this, you will have, I don't know, 5 or 10 of these on the test. Where here's the equation, sketch the graph, based off of the shifts and the stretches and all that kind of stuff. Okay, so I'm giving you a heads up, because you got a couple of days yet. You need to be able to do that. Okay, yeah?
If it's like, if we like multiply it by 2 to get more narrow.
Yep. In this one, or are you saying on this one?
Yeah, just in general, like for this one. If you just
Oh, yeah, if you're yeah, it would be more narrow, right? Yeah. So there's the graph of what we have. Notice, by the way, they said y is greater than or equal to 0. It is. That is the range. Which means, by the way, here's why this is here. If that's the range of my original function, what's the domain going to be of my inverse? X is going to be greater than or equal to 0. If this is the range of the original, remember, that becomes the domain of the inverse. So the domain is going to be that we're only going to look at the graph from x is greater than or equal to 0 because of that flipping. Now let's take a look. You'll see what I'm talking about in a second. Let's find the inverse. Let's flip the x and the y. And let's solve. Square both sides to get rid of the square root. Add the 2 over, and therefore x squared plus 2 is my inverse function. So there's that part of it. Let's graph it, and then we'll come back and talk about that domain idea again. What does this look like if I were to graph it? In general, we're dealing with x squared, so parabola, what's the plus 2 do? Up 2. Yep, that's a vertical shift, up 2, because that plus 2 is not in being squared. So if I move this up 2, the graph of that actually looks like this. Well, those are definitely not reflections of each other. Those are not the same thing, just reflected. But we said if that's the range of the original, that y is greater than or equal to 0, that becomes the domain of your inverse. What happens if I limit my domain to x greater than or equal to 0? What happens to that graph?
Can't cross x-axis.
Can't cross the y-axis. Gets rid of this half of the graph. Now are those inverses? Now you can hopefully see, if I draw my line y equals x in here, there they are. By doing that, this is the part where I told you we were going to add in today. By doing this, by having a restricted domain, it took that and now it made this a one-to-one function. Okay? That inverse would not have passed the horizontal line test, so it created a one-to-one function by limiting the domain. Okay, that's why we're doing it. You'll see a couple more examples in there. How we doing? Making some sense? Getting the idea? Coming together a little bit more, hopefully? Okay. Like I said, one of the things, also the reason why I keep coming back to the graphs is because, like I said, you will have, between 5 and 10 questions where I'm going to just give you an equation and you need to be able to graph it by hand with the shifts and the stretches and all that kind of stuff. So hopefully, on those previous assignments that I gave you, when I said make sure you graph it by hand and then use your calculator to check it, hopefully you didn't just type it into your calculator and sketch it, because you kind of screwed yourself on that if you did, okay? Hopefully you went through and you did it by hand and then checked. Because remember, you're only going to have a scientific calculator on the actual test itself. Yeah.
So for the inverse, do you always plug in x for the y?
Yeah. So like if it's restricted, yeah. Because it's now the domain, we got to switch the x and the y as well. Yeah, Preston?
So like when we get the first point down, then we can sketch it from there, right?
Yeah. The 1 point is the only thing I'm going to look. To give you a heads up, like in terms of how I would grade a graphing problem, I would say they're probably worth 2 points. 1 point for did you put the starting point in the right spot, and then the second point, did you then sketch it correctly from there? We'll look at it that way. Yeah.
Are we going to be graphing inverse functions on our test?
There's, I think, 2 questions where you're graphing inverses, yeah. And we'll do some more of that today. And I've got a very short assignment for you today. It's 5 questions total, where the problems I give you today will be very similar to the problems you're going to see on the test. So you'll have a chance to practice that. Okay? Yeah, Tina? I don't know off the top of my head, to be honest. I'll have to look again. It's front and back of 2 pages.
Is inverse worksheet number 2 what we're getting
Today.
today?
Yeah.
Okay.
That's the 5 questions.
Number 6, Mike?
Hold that thought for a second. I will come back. All right, let's take a look. Let's go into very quickly the 19 to 24 questions as well, because somebody in my first hour class asked, so we went over one. Then nobody asked in my third hour, but then as there was a little bit of work time at the end, I went around and had multiple people then ask me questions individually. So obviously there are some questions on that. So let's go over at least one of those. 19 to 24. If you have one, pick it. Otherwise, I'll just pick one myself. Any specific one you want to go over? 19 through 24?
Let's do 22.
Let's do 22. Sounds good. Let's take a look. Okay. So the question here says, are these inverses? And this is where we talked earlier. This is where you got to go do the composite functions and then see if it simplifies to x. So I'm going to start with taking the g of x equation and substituting it into f of x and see what we get. Okay? So I'm going to take the x out and put that equation in its place. So we have 2 times x plus 7 over 2 minus 7. Okay. Take the x out, put g of x in. And now simplify. Nice part here, this 2 and this 2 cancel out, leaving you with x plus 7, and then you still have a minus 7, which also then cancel out. There's your x right there. But that's not enough. We can't just do one. We got to make sure it works both with both composite functions. So now we go g of f of x. Now we take f of x and substitute it into g of x. We just go the other direction. So in place of this x, I'm going to put the 2x minus 7. So we have 2x minus 7, and then you've got the plus 7, all over 2. And now we simplify. Okay? Anytime you're dealing with a fraction, you should always get an answer on top, answer on bottom. So minus 7 and plus 7 cancel out. And then you get 2x over 2. 2's cancel out. There's your x. Those two are inverses of each other. Okay? Those two are inverses. So that gives you an idea of verifying again. Okay? Okay, now let's go to the back side. Let's go to the graphs here real quickly. And then if you have any other questions, we'll come back. Okay. I'm going to just do 25 and 26, and I'll show you kind of one main way of doing it that I think will be the easiest for you, and then we'll go from there. First thing I'm going to put in here, they ask you to graph the inverse based off of the original function. So first thing I'm going to put in, y equals x. I'm going to put that dotted line in. That's that 45-degree line that goes through where all the x and y coordinates are the same. So it's got 1, 1, 2, 2, 3, 3, 4, 4. All of those points are on that line. All right. Here's what I think is the easiest way to do it. Number one concept we talked about. Domain in the range, switch, right? Find some coordinates on the original and flip them. For example, here's a point right here. -2, 3. So, 3, -2. 3, -2. There's one point that's on the inverse. Then we find some other points. Even if you have to approximate, which we'll talk about in 26, here's another point. +2, +3. Flip the x and the y coordinates. So 3, 2. There's another point on the inverse. Okay. And just keep finding, yeah, there's -1, 0. So 0, -1. There's another point. And it looks like if you keep finding, here's the 5 points that are on the original that they actually put points. We'll match up here. Here's what the graph looks like. There's your graph of the inverse. Okay. Your parabola, when you reflect it over that line diagonally, goes from opening up to now it opens to the right instead. Okay. If we do that same concept on 26, it's a little bit different. Let's put the line in again. And once again, if we just find some points, one of the points I know it's going to be on the inverse is right here at the origin. It's on the line of reflection, therefore it doesn't go anywhere. Okay, it stays there. And if we now start finding some points, even on this one, this is why I picked this one. Let's say there's not even some nice points. It's okay to approximate. For example, let's say we take a look at the point. Looks like it's about -1.5, 3. I don't know for sure that that's the point, but it's close enough that I can approximate it. If it's -1.5, 3, go 3, -1.5. over 3 negative, there's approximately where that point will be located. Okay? Just find some random points, and it's okay to approximate those. Same thing down here. Let's say we're at positive 1.5, negative 3. Negative 3, positive 1.5. Switch the x-coordinates. Okay? And it might look like, right now, it looks like it's a line. Okay, it's not. Which means if you don't have enough points yet, then graph a few more to see what's going on. For example, the point 1, negative 1 looks like it's on the graph. So therefore, the point negative 1, 1 is going to be on the inverse. And same thing again, if I keep finding some points, ultimately, here's what the inverse will end up looking like. Looks something like that. So that S-shaped curve kind of, again, just like the parabola, kind of gets turned sideways. Instead of increasing and decreasing, it's going from left to right instead. Okay? I think that's probably the easiest way to graph the inverse. Find some points and just flip the coordinates. Use that concept of inverses to help you. All right. For now, take this sheet just for a second, put that aside. Let's go to your notes for a second. I want to solidify one last thing. You're not wrong. There is always one last thing. You're not wrong.
What, this one?
All right, I'm not going to spend a lot of time on this one. The second example, I'm going to spend more time because it's more what we're going to see. These problems and the ones, these are similar to what I'm going to give you for the 5 questions for homework. These are the types of problems you're going to see on the test. That's why I wanted to go over these, okay? So if you take a look, first question I ask you, is the function 1 to 1? Well, one of the easiest ways to answer that is to take a look at the graph, okay? So we have a cubic graph. What does the minus 2 do to the cubic function? Move it 2 down. Because the minus 2 is coming after it's being cubed. It's not attached to the x. So we're going to take our cubic function. We're going to move it down 2. And it will look something like that. So now now that I've got at least a sketch of the graph, now we should be able to answer that question. Does that pass the vertical line test?
Yes.
Does that pass the horizontal line test? Therefore, is it 1 to 1? Yep, it is. This is a 1-to-1 function, okay? Which means, I'm not going to do it on here because we just did a bunch of them on the assignment, but if yes, all right, find the inverse. So now you would flip the x and the y and you'd resolve and go from there, okay? If not, we would need to restrict the domain, kind of like on the 15 through 18, and that's what I'll focus on the next problem. Notice, all D and R stands for domain and range. Quick question on that. What's the domain of that graph?
All real numbers.
Yeah, domain, it goes all the way to the left, it goes all the way to the right, it's got everything in between, it's all real numbers. Which means if the domain is all real numbers, what's the range of the inverse? Domain and range flip. That means you know the range of the inverse right away. It's all real numbers. What's the range of that function?
All real numbers.
All real numbers again. Which means what's the domain of the inverse?
All real numbers.
Okay? So you really only need to find the domain and range of the original, and then when it flips, you've got the domain and range of the inverse already. Okay? To give you an example more specifically, that's not everything, here's the one I want to focus on. This is your one last thing. This is it.
So like, could you say that for every like even degree, you can always assume that it's not a function because at some point it's going to be going in the same direction?
Even degrees in general could be functions, but their inverses are probably not. Yeah, because they would all fail the horizontal line test. Right.
Could you just, instead of doing the graph and checking,
Yeah.
could you just fix the picture?
Yeah, you can. I'm only doing the graph because I think it helps. It helps see it, but it's not necessary. All right, let's take a look at this one. Let's kind of work our way through this process for this one. What's the graph of this one look like? Parabola. What's the plus 1 do? Up 1. All right, let's start there. There's our sketch of the graph right there. First question. Is this 1-to-1?
No.
Why not? It would fail the horizontal line test, right? That's a function, but the inverse is not going to be. So now, here's where we come up with some restrictions. How could I make that? How could I restrict that so that it would pass the horizontal line test? Alex? What if I did this? Now does it pass?
Yes.
X is greater than or equal to 0. You just restricted the domain so that now it is a 1-to-1 function. Okay? We took care of part of it that was keeping it from passing the horizontal line test. Which means, by the way, before we get into any inverses, what's the range going to be of the inverse? If that's your domain of the function, the range is going to be y is greater than or equal to 0. Okay? Now, let's actually do it. Let's find it. What's that? Yeah, you could have done it the other way too. You could have used the other half of the parabola.
Why would it be greater than equal to 0?
Hang on, we'll get there. Let's find the inverse. So here we go. We flip the x and the y. Let's resolve. Subtract the 1 over. To undo the square, take the square root of both sides. But again, remember, when you take the square root, plus or minus. Now, quick question. Let's kind of graph this as well to see what it looks like. We've got a square root function. What does the minus 1 do to my square root function? It's 1 to the right. All right, so here we go. 1 to the right. And now, positive square root, that would look like that. Here's where the restriction comes into play. We said x is greater than or equal to 0 for the domain of the original, which means the range of this function then is going to be y is greater than or equal to 0, which, how does that affect this? What does that eliminate? Gets rid of the negative part of it. We're not going to sketch in the bottom half because we restricted the parabola to half a parabola, so we're restricting it to just half of a square root, if you will, just the positive part. And again, if you can see it, hopefully you can see, there's your reflection right there. Okay? All right. I know it's a lot. There's a lot of things with inverses. There's a lot of details. There's a lot of things going on. And we did a lot today because I didn't want it to just be about inverses. I wanted you to go through and I wanted you to have the opportunity to see the graph and start working on some of that too, so it was more like a review as well. Okay? Let me hand out the assignment. There are 7 questions on the assignment. You may cross off the first 2. Okay? Because it's not that you can't do them, but for now, I don't want them to confuse you at this point. So I'm going to get rid of those 2. Okay? Not that bad. That's why I'm crossing them off. All right.
Like I can hear you see in my head exactly.